Okay, thank you very much. Thank you very much also for the applause. I'm really, really grateful and happy to be here in Kyiv for the first time in the Ukraine. And I'm really grateful to you all that you came to this session and to the conference, because for us speakers, it's important that the community gains something from our talks. So I'm really happy that you are all here, and hope that this talk will be at the top at your expectations. So, how are you holding up? Everything is okay? How are you? You're fine? Still rocking? Okay. Few more sessions to go today. And this is one of them. We'll talk about microservices. So, who of you have heard about microservices so far? Of course. How many of you did actually work on a real microservices project so far? Okay, quite a few hands. Oh, I didn't expect that, to be honest. But that's also a good opportunity, because what my talk concentrates on is not how great microservices are, that we always should do microservices, but this talk rather concentrates on the challenges that we had as a team when we were put to work on a microservices project. So probably some of my experiences, you had them too if you worked on that project from the beginning. Some maybe not. So I think we could also have a nice discussion afterwards to see exactly, okay, what my experiences were, what your experiences were, and maybe we can make this talk even better maybe for next sessions. Okay, so let's basically get started. Just a few words about me. My name is Dan. I am a software developer at Amdaris, which is a company based in the UK, but it has offices in Timișoara in Romania, where I work, and also in Moldova, where we do basically all kind of development in the .NET ecosystem. But I also founded like my own company, which is called Code Wrinkles. And through this company, I used to deliver trainings, both for people that want to start to learn programming, but also for companies that maybe want to improve the knowledge of their teams. And I also am the co-organizer of a .NET conference in Romania, which is called the Apex Vox, which will take place next week. So I'm also a little bit stressed with that part of things. So please excuse if my talk is not really, I don't know, the way you expect it. And I also have a blog. You can go on it. You can read a lot of things. I usually blog about .NET things. And I also have a Twitter account where I am fairly active. So we can get in touch basically anytime. So let's get started. First, let's look at the agenda. So very briefly, we will have a very short introduction to microservices. We will have an overview about what a microservice architecture is. And this just to make sure that we all go into this talk from the same page. And then I will briefly describe the project that we had to work on. And then, of course, I will go into the lessons that we've learned as a team working on that project. And of course, there were many lessons that we learned and a lot of challenges that we had, but I had to pick up basically 3 of them. So I will talk about the challenges that we had when we wanted to decompose services or define what services do we really need. Then we'll talk about messaging and the challenges that we had there. And then we'll talk about the idea of an API gateway and the challenges that we had there. And then we will draw some conclusions based on all these challenges, and we will try to discuss together and to see together if microservices is that great, or maybe microservices is great, but maybe in given circumstances. So we'll try to get a conclusion in the end of this talk. So let's get right into it. Microservice architecture. Here is a brief overview of a possible application, which is a car dealership or a car repair shop, which is written or created using this microservices architecture in mind. And what we see here is basically that we have different types of services that are totally independent. They communicate with each other through a message broker. And of course, there is an API gateway and an application on top of them, which allows basically to gather or to work with information from these different microservices. So what we can see here that each service is very strongly specialized on one important thing, and it does only that thing. So it's kind of like the single responsibility principle applied to architecture. And then we have the message bus, which is I would say, a central piece of any microservices architecture. And then we have supporting services, like notifications that have to be sent, emails that have to be sent, and so on. So this is the general idea of how such a project should look like. Now, when it comes to define in words what a microservice architecture is or what a service should be, first of all, it's small in size. And of course, here when we say small in size, it really depends, because when we say small, it's something that has also to do with perception, the way how we perceive things. Something that we might consider big in our projects, maybe companies like Facebook or Microsoft would consider small in their own projects. So what we did in our team when we tried to keep our services small and did this concept of small was mostly thinking about small in comparison to the other services that we have. So we shouldn't have a service that is, I don't know, double the size of all the other services. So we would consider that as a sign that that specific service, something is wrong with that, or maybe something is wrong with the others. But the idea is that we went on this idea to define small in comparison to the other services that we had. Then services should be messaging enabled, and we will talk about messaging a lot deeper during this talk and see exactly what type of messaging patterns can we have there. Then it should be bounded by context, and this is also an area that we will talk in a little bit more depth when I'll go through the decomposing part. Because we have to define, okay, what is a bounded context, and how can we really decompose our service by such a bounded context. Then all services should be autonomously developed, of course, ideally by totally different teams. So each team should be responsible only for one microservice, which has its own repo and build pipeline and everything. And of course, it should be also deployed independently. And this is one of the major, one of the key points of microservice architecture. So basically is that I have an application. If I change something to one of the services, I should be able to deploy that. And if something goes wrong with that deployment, basically all the other parts of the application will still work. Only the part that I deployed and that maybe failed will not work. And this is one of the major advantages that such an architecture gives you. And of course, it should be built and released in an automated process. So this is the ideal that we could have. And these are basically the concepts that we also tried to implement in our project. And we really tried to stick to each of them, of course, except with the autonomously developed, because I will come back to the project. We were basically a small team, so we didn't have a team for each service. And during the conclusions, we'll talk about if this is helpful or not. And the advantages that you see basically in all presentations is, of course, that your application will be scalable, because you can basically deploy and scale each service independently, especially if you're using cloud services like Azure App Service, or Kubernetes, whatever, you can easily scale those services. Or only the services that really needs more resources could easily be scaled up or scaled down and so on. You could be more agile, because in this perspective, when you develop something new, you probably, there is basically no way or no direct way in which you could affect the functionality of other services. So this gives you more agility. Then, of course, they are more available. So availability is another great advantage of microservices. And since you are really scalable, agile, then it really enables you to innovate faster. So theoretically, from the standpoint of a company, using a microservices architecture should enable that company to really be more agile and more competitive in their specific market. So what are the drawbacks? Do microservices have any drawbacks? Who thinks that microservices has drawbacks? Okay, okay, nice. Let's, however, discuss them at the end, after we go through the challenges. So, yeah. Good. Now the project. Let's talk a little bit about the project, because we have to understand exactly what we need to do there. I basically work for a client in Sweden that created, I would say, an entire ecosystem of different applications for call centers, or contact centers, how they are called in the US. And those applications in that ecosystem, some of them are fairly new, which are using .NET Core, MVC, and so on. But there are a lot of applications there, like also desktop applications, which are fairly old. And when I say fairly old, I mean maybe 10 or 15 years, and maybe that's not even too old, but most of them are desktop applications written in VB6. And I don't know how many of you are very familiar and comfortable of writing code in VB6, but I'm definitely not. So also the other developers are not really comfortable at writing VB6. So there was this idea that the entire ecosystem should be progressively, of course, translated to some more agile, more competitive applications. And the first thing that we received, that we needed to rebuild from scratch, I would say, was the so-called time and attendance service, or the application. That application was not really complicated itself. It's basically the application that would track when the agents in a call center will start working, when they go on break, when they finish their shift. And basically, at the end of a planning period, which is usually 1 month, it would create the timesheets for that agents with the total numbers of hours that they worked. And of course, this would, in order, generate an appropriate payment in a different system. So this was basically the application that we had. This application, as I said, was written in VB6. It was a desktop application, not easily maintainable, not easy to fix bugs. And from customers, there were a lot of requests to new features. And if an application is difficult to maintain, then of course it's also a nightmare to add new features. So this customer was, or is, in my opinion, fairly open to new things. And the CTO of that company said, sure, we'll do that, and we'll use microservices. So, of course, all the developers in our team were like, yeah, we'll finally go to build some microservices, which was, of course, cool, because we always hear about microservices at conferences, we read about them, and everything is like a fairy tale. But in reality, it's not very often that we really get to work on such a project. So we were really happy to have this goal, basically, to rebuild this time and attendance application using a microservice architecture and making it of course, a web application from the front-end perspective and so on. So this is the project that we needed to start working on. So as said, we were all very happy, like we were jumping of joy, yeah, we're gonna do microservices. So the next day, in the meeting that we had in the Scrum, we discussed, okay, we are doing microservices, everything. Yeah, we're doing microservices, great. Okay, but how do we start? What do we do? And of course, the first thing that we had to do, we realized that, okay, we have to define basically what microservices do we need. And this is what is commonly called like scoping or decomposing services. So you get a task, or you get an idea of an application that you need to build, and you have to define, basically, to draw exactly the services that you will need in that specific architecture. So we were around 7 developers on that team, and we looked at each other, okay, let's see. So we were not sure exactly how to do that. So the next step is we went on and looked at a lot of conference talks, readings, documentations, and so on. And when you do that, you basically will find 4 principles that you could use to decompose or scope microservices. And the first one that you see the most, basically, is decomposing by business capability. And as a developer, when you read this, of course, the first thing was, what the heck is business capability? So how do we really define that? Then the second most popular decomposition model that you will find is by using domain-driven design bounded contexts. Now, I won't dive deeper into what bounded contexts are, but just for an intro, basically a bounded context is a boundary in which a certain concept has a very specific meaning. And in a different boundary, the exact same concept or word may have a different meaning. In our code, this would translate maybe to the properties and methods that a certain class has. So I have an employee in one service that has first name, last name, ID, username, password, whatever, all the things. But for another service that just wants to, let's keep track when that employee started to take a call, that service, for that service, an employee would basically mean only an ID, maybe a first name and a last name, and that's it. So this is basically what a bounded context is, when a certain idea, a certain concept has different meanings, encode different properties and behavior, depending on the boundary in which you find yourself. And then there are a third and the fourth option that you will see in most documentation, which is decomposing or scoping by verb, and this would mean by an action that the microservices does, like for instance a shipping service, which would be a service that is responsible for shipping, of course, and to decompose or scope by nouns. And this would be basically to define a microservices by a word that defines exactly what the service stays for, like account service, which would mean that that service is really responsible for managing accounts. So the theory here is very simple. We have these 4 principles, so which one to use? And the complexity here, we didn't even think about this as a complexity until we had to decide that, actually. But there actually are a lot of problems that arise from all those type of decomposition models. Like, for instance, how you identify a bounded context. And of course, for this, you also need to have a very good domain logic. That company for which we worked to do that, they had this domain knowledge. But even for them, for the CTO and for their architect, it was kind of difficult to exactly define what bounded context would we need there. And this is due to the fact that in the entire ecosystem, it was easy to define different bounded contexts, but for that specific application that we had basically to create, it was difficult to do that, because that application itself could be a bounded context. So if we would have to redo the entire ecosystem using microservices, then this time and attendance would surely have been a microservice. But since we want to do only this time and attendance application in microservices, of course, it's a little bit more difficult to really define what the bounded context is. So the next thing was, okay, let's try to do it by business capability. And business capability, of course, means basically, a capability is something like sales. So you have a department that is responsible for sales. You have a department that is responsible for operations, and so on. But in our application, this was not really the case. So this would work great if you would have to create an application infrastructure or a microservice application for a company, like an intranet or something like that. In that case, making this decomposition by a business capability would be okay, probably. But in our case, it was not 100% accurate. So we asked ourselves which decomposition model is the best, or what should we do? And we realized, basically, that it's impossible, practically, to follow only one of those models. So you had, basically, to follow more of them, or try to be a little bit more relaxed. And this is basically one of the first things that we learned there. Don't take anything by the letter. Try to understand the principles behind, but then try to apply them to your given scenario. So what we did, and I'll briefly show a little bit of code here in Visual Studio. Here, this is basically one solution that we have put together for demo purposes and conferences, where we put together all the different services. And what we did here is basically we defined that, okay, we surely have one bounded context there, and this would be this timesheet service. And we can see that this is, well, one bounded context because it's actually the only one that has, for instance, data access, domain, services, and so on. And there is another service, TA time punch, that should also be in the same microservice or in the same bounded context. But when we started to do this demo application, we had this separate project and we didn't port it so far. But here notice the idea is that we have one service that we have decomposed by the bounded context, which is the timesheet service, because this is the main thing that the application should do. It should basically aggregate all the information and create the timesheets for all the agents. But then we realized that most of the other services that we would need for these specific applications are nothing else than supporting services. So in this case, we try to decompose them or name them simply by noun. So we have here like a TA account service. And this would be a service responsible, of course, for managing accounts. We have the TA agreement service, which is responsible to manage agreements, which are, in our case, like contracts between the call center and the different agents. Then we have the gateway. To the gateway will come a little bit later, and we have also a service for authentication. And I will come to that a little bit later. But the main idea here was that we used one service we decomposed using the bounded context decomposition model, but for the others, we basically used the noun decomposition model. But until we came to this conclusion, we sat down and discussed a lot of options for, I think, 2 or 3 days. So yeah, it was not really easy. But there we go. So we got over it. We finally defined our services. So we are good to go. And then we stumbled upon the next thing. So it was right after we were happy that we have our services, but now the services have to communicate between them. Of course, we have to use a message broker. And there we also tried to understand exactly, or to understand better what we needed to do, what options do we have, what patterns could we have there. And a problem is that microservices should communicate, but how exactly should they communicate? Because it could be that services would talk to each other synchronously, so that services call each other, which is normally not desirable and not recommended in a microservices architecture, but there are scenarios where this might actually be useful, and we'll look into that. Should we use instead some async messaging, like RabbitMQ or other message buses? Or should we use transactional messaging and different other types of ways to communicate basically between microservices? So this is what you will find as usually as communication patterns. So synchronous calls, this would be when a service calls a different service via an API or via GraphQL, maybe. Okay, and in cases, for instance, when you just do some queries, where you don't actually modify any type of state in the application, maybe the idea to have synchronous calls is not that bad even. You could do this also in circumstances, or you can use even a gRPC maybe. So there are different ways that you could communicate synchronously without the need of a message broker. However, we found out that synchronous communication led us to a lot of, I would say, challenges with our Docker customization and building and deploying and so on. So it was kind of like a little bit crazy. So in the end, we found this second option, which is the most popular, I would say, which is I would call here simple messaging. But the idea here is that you use basically a message bus, a message broker, And all communications will go through that broker. And this is useful basically also when you send some state changes commands between services, but you can use it, of course, even if you want to do queries. And then the third option that you will see often in documentations as a communication pattern is the transactional messaging pattern. And this means basically that we have to make always sure that everything is communicated properly. So when a service wants to communicate to one service, it should start a transaction, it should persist it, of course, then the receiving service should do the same thing. And if anything would go wrong in that communication, that each service independently should be able basically to redo what it has done so far. So you can also use that. Of course, we went for the second option, so where we have the simple messaging, and we decided to use RabbitMQ as a message bus. Now, the problem with RabbitMQ and in general with all message buses is that they really add a lot of complexity to your application. Because if you do that, you suddenly have a lot of concepts and a lot of things that you have to take care of. Like, for instance, we always have a producer, which is the service that produces a certain message. We have an exchange, which is basically something that defines different type of queues and the way that that messages flow from one service to another depending on those queues. And those queues are of different types. Like, we can have direct, we can have topic, like for instance, only for certain topics it should redirect a certain message to a certain server, or it could have a fan out, which when it receives a message, the queue sends it to all the queues. So it fans it out to all the queues that it knows about. Then the queue, of course, is basically, the buffer that really contains the message, and from where the services would take that type of information. And this is, let's say, from a memory perspective, only bounded by the amount of memory that you have on the machine that it is hosting. But then we have also a consumer, which are the services that consume that type of message. And suddenly, when you want to have a message broker, you have to configure and to think about all of these different concepts. And of course, what we did is, let's keep it simple. No? There is this principle, keep it simple and stupid, or smart. So what we did is, okay, all exchanges, in our case, are fan out. So when a service puts a message on the bus, basically the exchange will send that message to all the different queues. And each service, based on the message type, will basically define if it really wants to do something about that message, or simply ignore that message. Of course, this worked very, very fine until we started to really test a little bit our application, and when we arrived at around, 3,000 messages per second, things started to break down. So in the end, this was not a very good idea. And believe me, for a call center, 3,000 messages per second is not necessarily something big. It's like it would have been an average. So of course, then we had to start to investigate and look into what topics are and create different topics and try to define exchanges that redirect to only certain topics. So basically to optimize the entire message bus. So a thing that we thought, okay, that's simple, we simply do it. In the end, we spent then, I think, 2 weeks on trying to really fix it and make it work for really, I would say, plausible numbers of messages. And I want to briefly show you also how our messaging infrastructure looks like. In the demo, it's still using fan out. So here we have the infrastructure messaging, and basically there are two services that are important here. We have a message publisher, which is basically responsible to publish a certain message, and we also use poly for retrying. And we have a message handler, which is of course responsible for handling a message once that message arrives to a certain queue. So this is basically how we build them up. But what I wanted to show you is how we basically use them. And here, for instance, we have this TA account service. So when we create an account, what we do basically is that at a certain point, we see that we create a new type of message, which has the name here of account set. And we set here different properties. Then what we do is basically publish this message. So we publish it. On the other hand, for instance, we have the TA employee, and this is the microservice which is responsible for handling or managing employees. And here, for instance, we see that in the startup.cs file, but this is the HTTP post. Let's go in the startup.cs. Okay, here we configure what we want to do when we start a RabbitMQ, but here we also register a message handler. And for this, we have this event collector that uses that message handler. And basically what we have here is we have a switch statement. And if we receive a message type, a message that is of type account update, so if an account was updated, then we do something with it. If we receive a message that is of time agreement update, we do something with it. If we receive any other message, we simply don't do anything. So we don't care if we receive in that queue a different message. What I wanted also to show you here, the different meanings of different types here. Like, for instance, if we go here on this account entity, okay, we see that we have here, okay, the object ID, I don't know, I pressed the wrong key. We have the account ID, we have the name, and we have some settings. What we will see is when we, I don't have internet, so it won't work, but when we go, for instance, on the account, on TA account, when we try to see basically what this, this account set is, basically we see that it has more properties. So this is the difference. In the account service, one account has more properties, has more information with it, but in the employee service only cares about some settings and about the ID of that account. So, so that's basically it, how we publish and how we can use different messages here. Okay, then let's go one step further. And the third problem that we had, unfortunately, after we fixed the decomposition, after we fixed the messaging, we had some time where we really developed our services. And at a certain point, we realized that, okay, all these services, each service was running on a different host and port. So when we wanted to build the front end, the web application, that web application basically should know each and every host name and port, and exactly the documentation, basically, of each service, which, of course, is not optimal. And this is when we have to think about API gateways. So the idea of an API gateway is nothing else than to be an umbrella on top of your microservices. So basically, using a gateway, all the consumers of those services, they will only have to know the host name and the IP address and the documentation, I would say, of the gateway. So a client would make a request to the gateway should be able to define or to understand exactly what information the client needs, and it needs to contact the appropriate microservice, which will provide that information, and the gateway will then send it back. So this is what we normally call proxying. But a gateway, an API gateway, should be able to do different things. It should be able to do service discovery. And service discovery is a very important concept, especially when you deploy such an architecture to Kubernetes or something similar, where you don't easily know the IP address or host name and port. So the API gateway needs to know how to interact with this type of services and find out exactly where to find the service that should get a response for a given request. It should also be able to do response aggregation. What this actually means is that, okay, basically I have a request. For instance, let's think about this from the perspective of the web application. So I'm the web application, the front end. So I want to get information about, I don't know, a planning period for a certain agent. So how many hours did he work? In reality, to get this information, I might need basically to interact with different services. I would have probably to call the account service to get the information about the account. I would have to call the employee service to get the information about the employee, like first name, last name, department, team, whatever. And I will have to call the timesheet service to really get the timesheet. So me as a front-end, I would have to do 3 different calls through the API gateway, of course, that would give me that information. So what if an API gateway could know to aggregate this type of responses, so that you send one request and say, hey, I need the timesheets for a certain agent, and the API gateway should then be able to make the different calls that it needs to aggregate that certain response. So this is one very important thing that the gateway should do. Another thing that the gateway should do would be header transformation. So it should be able to transform headers. Why? Because, of course, since your gateway is the entry point to your entire application, you might want to forward some type of information to your microservices that they could use in order to service that specific request. Like maybe if it is authenticated, authorized from what IP, it came from whatever. So a gateway should be able to do this. It should be able to translate between HTTP and HTTPS. It should be able also to do load balancing, because of course if you have microservices, you surely won't have only one instance of one service, you would have several. So the gateway should be able to do that, to do a certain type of load balancing. It should be able to do authorization and authentication, and it should be able to also do rate limiting or throttling. So where to find that? Basically, all major cloud providers have services that cover this type of functionalities, or at least in part. Like Azure has API gateways, Amazon has API gateways, Kubernetes has a similar functionality. However, one problem that we had here is that we had the technical depth as a really big drawback. And why was that? Simply, the idea was that we built everything in .NET Core and basically in the .NET ecosystem, but recently, before we started to work on this project, Amazon opened a data center in Sweden, and the customer was from Sweden. And suddenly, the customer said, hoppa, maybe we don't want to use Azure anymore, maybe we want to transition to AWS. So we wanted a solution that would allow us to basically easily switch maybe from one platform to another. So we found this really great library, which is called OSLOT. And this library helps you to implement an API gateway very, very easily. And it really covers all the requirements that I said that an API gateway should cover. And it's open source. It's also backed by Microsoft. By now, it's also in the official Microsoft documentation, although it's not developed by Microsoft. And the really cool thing is that it's fully built for .NET Core, taking advantage of what the middleware is and all the advantages of HTTP Client Factory. And if there is functionality that you don't find there by default, you can extend it just by using middleware or HTTP handlers and so on. So it's really powerful in that way. And what I wanted to show you as a demo here, to show you the thing that we found very, very cool, is that basically you don't have to write any line of code to get going with it, which I think for all developers is cool. So okay, I have a library, I can have a powerful API gateway, and I don't have to write any line of code. That's cool. So I can go and drink a coffee instead. So let's look a little bit at this API gateway. And here, what we have here is basically in startup, we don't have anything. so it's completely empty. Truth is that in program.cs we have a few things, but it's more or less the startup of a normal .NET Core application, to which we added some services for JOT authentication and authorization and so on. And basically, the only thing that we have done is used this use allslot middleware, which comes from the library, with the wait, to wait exactly for the response to be generated. If you want, we can discuss about allslot separately after this talk. I also give talks on allslot where I go in depth on how this works and so on. But for now, we just use this middleware, and basically that's it. So where do we have everything that is around allslot? It is in a JSON file. So everything here in allslot is configurable using JSON objects. And you have two major parts, which is a reroute array. And the reroute is nothing else than defining a certain service to which the API gateway should be able to route a certain request. And for instance, here we have two types of concepts like downstream path templates or downstream path, which is the microservices that the gateway should call, and the upstream path, which is the URL to which the client makes the request, so the URL of the API gateway. So basically what this says is that when you receive a request for API/accounts, you should make a call to the downstream path API/accounts for the host account API on the port 5900. And each time a request will come for the API gateway /API/accounts, the gateway will make a request to this service and will basically give you the response. If you run the service on several instances, you can define here several different objects, and you can then also configure load balancing for them. And one other cool stuff that we used here is the header transformation. And what we did with the header transformation was that we also wanted to have authentication and authorization. The good thing when you have an API gateway is that you can centrally enforce security policies on the gateway level. However, we had claims in our JOT tokens that were fairly specific for certain types of logic that we want to implement, like which is the team to which a user would belong and so on. So we needed to transfer this information in some way from the JOT token, where they were coded as claims, to the service itself. So how to do that? Of course, with headers. So what we do is simply that for each request for this type of URL, basically we will try to look in the JOT token in the claims, find the claim account ID, and use that value in a header, and then create another header, which is named employee ID, look in the claims on the JOT token, search for the claim which is called employee ID, take the value and use it basically as a HTTP header. So when the request arrives to the service, what happens is basically that the service exactly knows from what account ID and what employee this type of request was coming, and based on that, of course, we could implement logic like what information is that user able to access and what information not, so doing some real authorization with it. So as conclusions, let's say, microservices is a really cool architecture from my point of view, and it's really nice to work with it. However, we got the feeling that specifically for this project, this microservices approach was not really beneficial, because we invested a lot of times in challenges that we had, and we could have built this entire application way more faster using a normal application design, maybe clean architecture, and so on. It would have still been a very performant application, but microservices wouldn't have been needed for this application specifically, because it really adds a lot of complexity. So the idea is that we should think about it when we want to start such a project. Are the complexities outnumbering the benefits? If yes, maybe using this architecture is not an optimal choice. If on the other side the benefits are outnumbering the complexities, then probably it is a useful choice. Then one other thing that we found out is that microservices is not only about application architecture. It is also about how the organization works, how many teams are involved. Because as said, we were only one team. Of course, we were more or less responsible for one or two services, each of us. But working like that, there were, so practically you will always have situations when you say, okay, but let's just quickly fix that type of part which is in a different service that developed the other guy, and you will get some conflict, some bugs from that. So microservices in its ideal, I would say, concept should be applied where we have also the organizational structure, when we can have dedicated teams to each service. And that those teams should really work independently one of the other. And this was, of course, or clearly not the case for our application. So my conclusion would be that before deciding on going for a microservice architecture, we should try to ask ourselves if it's really worked. Because in our case, maybe we would have been faster and the application would have been, let's say, more or less the same, even if we didn't go for the microservices architecture. So, that's basically it. If you have any questions, how much time do we still have? Okay, so if you have questions, yeah?
First of all, thank you for a great talk. It was very interesting. And my question is, you said that you had quite a big ecosystem, yeah? And a part of that was the application that you rebuilt. So did you have a necessity to interact with this ecosystem, and how you did it, if yes?
Basically, yeah, that's a really good question. The idea was that our application that we have built should be rebuilt from scratch. This being said, of course, there were some type of information that we still have to get from some existing databases. But apart from that, what we really needed, very small chunks, a very, very specific one, everything in this application was basically totally separate. Why did we do this? Because the main goal of this company is, as said for more years, to bring their entire ecosystem to this microservice architecture. And in that case, basically, each type of application would be 100% self-sufficient, like each microservice should be, with own databases and so on. So yeah, right now we still have to make some call to existing databases, but we really keep them to a minimum, to only the information that we need. All other things is we are calculating on the microservices itself, where we have each service has its own storage and so on. Thank you for the question.
Anybody else? Thank you for your talk, first of all. And I have such a question. You were talking about API gateway. So one of the main parts of its functionality is gathering the responses from different microservices and combining them. So my question is related to Ocelot. Does it allow us to do some aggregation of the responses?
Yes.
Or this
yes.
part of logic should be customized?
No, it's definitely there. In fact, what you have seen there is only a very small part of the gateway that we use right now. But the configuration for only one endpoint doesn't even go on one slide. So it's big. And you can define, you can also define this type of response aggregation. So Ocelot fully supports that. It was from the first features that it had when it was released.
Okay, thank you.
Yeah, you're welcome. Here, I see another hand.
Thank you. Hi, thank you for your talk. And my question is about message broker and API gateway. And Why do you need a API gateway and load balancer in this gateway if message broker can do this work? Why not to publish just these messages directly to message broker from web UI, for
Because
example?
there are things that are harder to do using simple messaging, like authorization, where we work with JOT tokens, like we have our own identity server implementation, we create our JOTs, and the gateway receives them, it should be able to process them, to extract from their information that we put on the header. So this is a type of task that you cannot simply do with messaging. So our idea was that we wanted to have this central point of entrance in the application that was used by also the front end, but basically later, anybody who would like could create their own front ends for this type of information that we had there. So in fact, also there were some customer in the US of this customer that I am working on, that they want to build some on their own front ends based on the information that they would get from that application. So we would need this centrally point of entrance in the application also for that.
Okay, and one more question. Why did you choose RabbitMQ? And have you faced with duplicate messages?
Okay.
Thank you.
Yeah, in fact, the trouble with duplicate messages we had, that's true. But the idea was that we had a workaround for now. When we had a message, basically, we look for some information, or we have certain circumstances in which we think that the message is duplicate. So every time we have a message, we also check if we had a similar message before. This is not optimal, but when you're using a document database, it can be held in a very acceptable performance. And also we noticed that there were some services that could basically generate duplicate messages, but not other services. So in that case, we could also define or see better where the problem is. So we worked also why, or to check exactly why these duplicate messages were there. And why we choose RabbitMQ, to be honest, I really don't know. We simply choose it. So yeah, but joke aside, some of the things were not directly decided by me or by the other developers. It was directly decided by the CTO of the company, and his idea was we should use RabbitMQ. And of course, also his idea was, for instance, that we shouldn't use any serverless or other fancy stuff, again, for the reason that they want to easily port that type of application to different platforms. So we had to go with it. So I won't say that use RabbitMQ, it is the best. I don't know if it's the best. It's the one we used. And it worked, I would say, acceptably when we started to really understand how it is supposed to work and really use it in an optimal way, let's say. Good. Thank you for the question.
Good. We still have 1 minute for the question. Please do it very briefly, if possible.
Thank you. I would like to ask you, how have you achieved the transaction between 2 or more microservices? For example, you want to save employee, and then after that to save something on an account?
We didn't implement any transactions. So we didn't implement that transactional pattern at all for now. We just, when you create an account, the service then publishes the message, a new account was created. The employee service would create then, or would save the information that the new account was created. But there is no kind of transaction or something like that. So it's not followed. And to be honest, we didn't have any problems with this approach for now, at least. So, yeah.
Good.
Okay, sorry. I also usually like when I am at a conference, which is 2 days, or when I start the conference to make some recommendations for the sessions. Not that they are good, but they are sessions that based on my interests, I think I will attend. I will have a session on Blazor tomorrow, architecting Blazor applications. with an approach inspired by Angular. Then another cool session related to microservices is Forget About HTTP, which is also tomorrow. I think it's the first session. Then GraphQL, because I said about synchronous communication and we could use GraphQL, and there is a very cool library called Hot Chocolate, which is written by Michael Steib, which is here. And I strongly encourage you to go to that talk because it will change the way you think about GraphQL, I guess. Then there is also a talk on Blazor, which is the future of web. And this is like a more the introduction talk, and then my talk comes afterwards. So if you really want to get more information about Blazor in this conference, you should attend these talks in that specific order. And then there is, I see that everybody likes performance sessions here, so there is one more with the daily performance fuck-ups, which is delivered also tomorrow, and also 6 lessons that were learned during transition from a monolith to microservices. So all these sessions are kind of related to what I delivered here or what I will deliver tomorrow about Blazor. So I will kindly invite you to go to them if they sound familiar to you. This being said, thank you really very much. I appreciate you being here and hope to see you then tomorrow.